Hello, welcome back to Blender Live Noding. In this episode, I want to do a little bit of just improvisation using animation nodes, and it's gonna be about sine wave and maybe a bit of cycles of Eevee just to make like an LED kind of setup. So let's get started. So we have empty scene as usual, create animation nodes, create new objects. Let's start with a line mesh, crashing a lot in this version of Blender. Is that 2.8? Let's see if this works. So animation nodes, new line mesh. Okay, file save as an LED. So let's see, line mesh is to place like a grid of objects. I can use this cube, I guess. So this is gonna be the master cube, and we're gonna use object instancer. Let's hope that this doesn't crash. Grab our box and instance the objects using just object transform. So we have here our objects. Where's our locations? Our locations can be from the mesh. We're gonna use mesh info. Just grab the vertices. So we have like an invisible line, and we are instancing this guy based on the number of vertices of these invisible lines. Okay, so there you go. Because thanks to this line, we have a way to just distribute this cube. Now let's do it like that. So 10 cube, thanks to this master cube, we have 10 cubes that we can play around with. We can make it like up and down using sine wave or things like that. I'll show you. Float math, sine wave, but this math, of course, is taking only a number, multiple numbers, but not a vector. So we need to separate the vector of this line vertices, and based on the x positions, make it ups and down for its z. So the x will be the same, the y is actually 0. There you go. And if you want it to be animating, of course we need to move the value. So use another math, just add a frame. So this is kind of like something that's become really easy to do thanks to animation nodes, and this is actually very interesting. In the past it will be like quite complex and it's so hard to visualize this. Maybe you can do this with particles or things like that, but this is incredible. And with the sine wave, of course, you already know you can multiply, things like that. So sine wave, and so this is too fast. Multiply the time, make it slower. There you go. You already know all this. What will be nice is if we use this sine wave to drive the box. So instead of the box moving up and down, we're gonna make it kind of blinky. So we will need maybe Eevee or cycles render to see the light if we are gonna be emitting the light. So this cube can be hidden. So we have light, we can delete the light. So we have this motion. We're gonna apply some kind of emission material into this guy. So let me think. The instance, actually, the original cube itself might need to be, oh, it's already have material. Okay, cool. So we are gonna jump to shader editor, and we will be using emission, just emission, and the emissions will be controlled using the sine wave. But in order to do that for each and every objects, we need to have some kind of attribute, like a specific attribute for each object. In this case, I will use this vertex color. So we don't have vertex color yet, but we're gonna use animation nodes to do that. So back to animation nodes. For each object, I will apply a color, vertex color. So for each object, oh, I have to do it inside a loop. Tab W, loop through the objects, and for each object, simply assign a color. We can test it with a random color first. So combine color. Random color can be, we can use the HSV, and we can drive this value. Random number based on the index 0 to 1, plug into the hue. This goes to the color, and we should be seeing color. Yep. So this color is driven by this guy. Random number goes into the hue, and we have this. Pretty cool. But we want to actually drive the emission value. So let's actually split this so we can see the shader editor. Look at the material. We don't need this principle. We have attribute goes into the emissions. We need a way to control the strength. So the strength, we actually have cycles material output here, so we can drive the strength using animation nodes. Although you can actually use another vertex color to drive it. So maybe instead of using this, I will use another vertex color. So it's going to be the strength of each and every object. It's going to be driven by, so we have strength. So this vertex color is actually hiding in here. Color, we should have another one coming soon from here. Let's try, instead of random number, we're gonna use a sine wave that's coming from this guy. So which value that's currently changing and making the wave is actually all this that goes into the Z. So the Z, we can just plug the Z into this guy and use it as the strength. So create a new iterator, call it a float list. Float list coming from this guy. So there's a value, and this value can go into the strength. Actually, it's expecting a color, so it can be plugged into the value. This goes in there. So let's take a look if we replace the color with the strength. Okay, now it makes sense. Let's see, RGB, HSL. Just look at the value, and then we have control over the hue, and we have control over the saturations. But this is where it gets quite interesting. Is we have control over this value, and maybe we can kind of offset it. So I'm offsetting up the value. So now we see all the red. But this is actually the beginning of where it's going to be a little bit more interesting. Maybe we can multiply the value. But it's actually the value from the strings. I want to pass it into this guy. So it should emit more. I wonder if this works if I'm switching to cycles. Yeah, it does. Let's stop this and create a plane. It should be emitting. And the light currently coming from global world. Just turn it off. So we have light. The strength is here. Maybe we can multiply the strength as well. So now it's really emitting. With Eevee, the advantage of Eevee is that you have glow, bloom. So it feels pretty cool like this. Let's see, select our objects and let's see if this, you see, this actually have effects on our setup, this bloom. So this is actually pretty much what I want to show you. So we have color, random color coming from this guy. So it's almost like an LED setup. You can definitely play around with these ideas. The sine wave controlling this guy. The animation is of course interesting, but you don't actually need to see the animations. Like if I just simply put it back to the floor, now we have some kind of LED. So I can perhaps control the position of this cube. Oh, actually the position of the cube actually affecting the animation and the LED as well, so that's interesting. Let's go back. All right. In that case, we really just use the animation, the animated version of the LED. A better way to visualize this is that if you have like a curve somewhere and then maybe another visualization. So before, instead of seeing all this cube doing its stuff, doing its thing, maybe you probably just have a curve for that. So I don't know why. Okay, so that's how it started. Okay, this is clearer. That's why in this one, it's almost like you don't have some of the boxes kind of disappear because it's black color. This one, okay, you kind of understand what's going on. So you can further play around with this. So this seems to be offsetting the value for the intensity of the light. But if I make it minus, so it's become like upside down. So we multiply to 1, so we can control the hue over here. Saturations, it's also having some effects. There's alpha as well for the vertex, but we are not really using that. Let me see. What happens if we have noise and multiply the strength? So we have the color, which is up there. You don't need to worry. We have this something that controlling the strength. Noise. Let's try noise. In animation nodes, we have vector noise. We don't have a single scalar noise, but we can use this. Vector noise can be coming from the line itself. So vector goes in. There's a value. Okay, the value is actually, this is a scalar noise, it's not a vector noise. It's not like 3D noise. Okay, so we can bring in the noise as float. Noise goes in there. What if we use the noise to drive just the value? So that's what we are getting. Not very exciting, but it's interesting. If it's like an LED, we have some kind of noise. Is it really moving? Not sure. Maybe multiply the noise with our sine wave. Sine wave, in a way, sine wave is actually more interesting for a lot of examples. If you use just sine and cosine and math formula, it's more interesting than the noise. But combining the two can be like a quick way to get something that's a little bit more interesting. So there's a sine wave happening. The noise is disturbing just the light itself. Maybe it's flickering and doing something. Let's play around with the amplitude and things like that. Frequency. Okay, frequency, I know it's going a little bit crazy. Okay, vector noise also have offset, so that's interesting. So I can offset the noise. Let's see. Amplitude, less amplitude, more amplitude. Frequency, okay, less frequency, less blinking. You can get like a really subtle effects. But you're not limited to just sine wave now, because this thing is also moving. It seems like very sophisticated setup, but it's actually really simple, as you can already see. Something that we can set up in just a few minutes. You can just replace this line with a maybe grid, and we should get a different result. Okay, this is a grid mesh, 10 by 10. Still doing the sine wave thing, but can be more complex. Let's look at it without any color. It's that simple. And in fact, if you get rid of the animations all the way here, you can see the noise, the effects of the noise and the sine wave into this guy. Try if I unplug the noise. So that's the sine wave on this LED panel. That's the noise affecting the sine wave. If you notice, the box size is not the same. That's because I'm scaling this master at some point. So if I go back to the instance, I can perhaps reset the instance. So Blender 2.0 is crashing. Let's try reopening. Let's see if this crashes again or not. turn off this guy and just reset. Yep, it's good. Enable this. By the way, this always and auto execution can be quite heavy on your computer. So I'm not, if you're using animation nodes and Blender, don't leave it overnight with animation nodes set to always. It can be really processor intensive, and the fans of your computer will be very loud all night, and yeah. Oh, I think I did reset this, right? Reset. No, it didn't crash. Okay, cool. Save as. Run the animations. Maybe reopen it. Oh, okay, interesting. So I guess that's probably pretty much it. What I want to show you today is just another recap on the old setup. So the animation nodes doesn't seem to work after I reset the instance. That's interesting. Maybe a bug, but at least I managed to make it to work up to here. It crashes. Well, that's probably a bug, and that's pretty much live noding for today. Let me know what you think, and I'll see you next time. Thank you. Bye.